begin.
Okay, so we've got the Chocolate Caramel Confection Corporation Chocolate Caramel Confection Carrier, aka the CCCCCCCC, or Project Octane. So our client company is Donut Hut. Our target consumer is the sort of person who consumes chocolate caramel confections. Our lead engineers are Raj, myself, Thomas, and Jordan. Our problem is we need some way to maneuver our 1 kilogram of chocolate caramel confections upward by 1 foot, or approximately some number of centimeters. Our design statement, we will design a frame made with a large wheel and axle at the top. The large input wheel will be a crank handle, and the smaller wheel will be used to wind string in order to operate a pulley. The pulley will then slide the weight up a long inclined plane. Our criteria and constraints: it must be made from VEX equipment, it must lift 1 kilogram, 12 inches, it must include 3 to 6 individual mechanisms, have a minimum actual mechanical advantage of 3, must be as light as possible, and not exceed in any primary axis more than 24 inches, must be easy to store and disassemble, and must be able to measure the force with an input meter. Our weight on our final product came out to 3.4 pounds, the cost being at $10,000 a pound comes out to $34,000. It's relatively inexpensive. Here's our brainstorming. We included much of our design ideas were we knew we wanted to do a big wheel in order to maximize our mechanical advantage, as well as a pulley. Then we had several ideas for what to end on, including using a screw, which would maximize mechanical advantage, as well as possibly a lever or a pulley. We ended up deciding on big wheel to pulley to inclined plane, which is over there. Here's our design matrix of the different designs. I believe this one was screw. We didn't like it very much. It would not have worked. These ones would have been probably lever and pulley. Yes. Okay. So here is our pulley system and our inclined plane. As you can see, the wheel over here turns this portion, pulling on the string of the pulley in order to lift the weight up the inclined plane. And here we have the, wait, this is not the video yet. So yes, here's our wheel, which is really just one large functional wrench sort of system, going into the axle here, thus lifting the pulley and the weight. And here we see fellow engineer Jordan operating the system. And there you have your chocolate caramel confections. The overall actual mechanical advantage of our machine is 109. The ideal mechanical advantage is 140. Here's the breakdown of that. We have our pulley is at 2.0. Our inclined plane is at 1.6. Our wheel and axle is at 44. I think that might be a good sized chunk of it. And our efficiency is at 77.85, so not perfect, but pretty good. Given the actual end result, pretty good. That's it. Thank you, everybody. We hope that you will consider buying some chocolate caramel confections soon.
Bye from Donut Hut.
Bye from Donut.